Hi children, welcome back. Really quick lesson today to cover up two important things that I missed from my past two lessons. We're finally done with lesson one, so we can actually do some physics next week. So here we go. Quick review. So I'm like 5'11", which is about 1.8 meters. Figure out your height in meters. So if you know it in feet and inches, convert from, find the total number of inches. There's 2.54 centimeters an inch. Tell me your height in meters right now. Good job, you did it. Okay. So how much taller or shorter are you than me compared to yourself? You might be like 2 inches taller, or 2 centimeters taller, 5 centimeters shorter, 3 centimeters taller. I don't know. It doesn't matter. If we're comparing the heights of different people, it makes sense to say I'm X taller, I'm X shorter. If you want to find my height from yours or your height from mine, you could add or subtract a small amount, and that makes sense. But it doesn't really make sense if you compare the height of a person to like something much smaller or much bigger. Like, sure, if I say, oh, I'm like 20 centimeters taller than my sister, that makes sense. But if I compare myself to like a little tiny lizard, like a little baby gecko, maybe the gecko is 1.8 centimeters or 0.018 meters. If I compare myself to a tiny ant, which I magnified, maybe the ant, I don't know, is like 1.8 millimeters. That'd be 0.0018 meters. When I say, oh, I'm 180 centimeters taller than an ant, when I say I'm 180 centimeters taller than a gecko, technically true, approximately true, but not very useful because ants and geckos are not the same size. Geckos like eat ants, or they do hypothetically in my imaginary story. I'm not teaching you bio, I'm teaching you physics, so deal with it. It doesn't really make sense to compare their height and say, oh, I'm this much taller, this much smaller, this much bigger, whatever. We're going to use order of magnitude to compare things. And this is related to what we were talking about when I had you guys estimate things. It's not important exactly how much bigger or smaller something is. It's not important exactly the comparison. You just want a relative comparison to see how something, to know something is way, way bigger or just bigger. Like, are you comparing a person to a country or a planet or a galaxy? Something very, very different in size. It doesn't really make sense to say, oh, it's the Earth is like a million meters bigger than I am. No, it's much more useful for many things to express how many times bigger. Instead of saying you have to add or subtract, say I'm this much taller, say I'm this many times bigger or this many times smaller. So it's a real simple trick. You may have looked it up online. Here it is. Just take the number 1.8 meters or 0.018 or 0.0018. Turn them into scientific notation. They have to be in proper scientific notation, which means that it has to be something dot something times 10 to some power. You couldn't say 18 times 10 to negative 1. You couldn't say 0.18 times 10 to the first power. That doesn't make sense. There has to be one digit to the left of the decimal, and all the rest must be to the right. So 1.8 meters is 1.8 times 10 to the 0th power meters. This is 1.8 times 10 to the 1 to negative 2 meters. And this is 1.8 times 10 to the negative 3 meters. When I say order of magnitude, it has the word magnitude. If you don't know, that means size. We'll come back to that later. It's not super important right now. Order of magnitude, you look at the number to the left of the multiplication sign, the coefficient, 1.8. Totally ignore it. It doesn't matter at all. We don't care what that says. This digit right here is the order of magnitude. 0 -2, -3. Not 10 to the 0, 10 to -2, 10 to -3, just 0, -2, -3. So a human height is on the order of magnitude in meters of 0. It's a 0 order of magnitude because it's somewhere around 1 meter. Even if you were a super tall like basketball player that you were like 2.2 meters tall, even if you're like a little person like Peter Dinklage and you're like 1. I have no idea, 1.2, 1.3 meters tall, that's the same order of magnitude. It's not important how specific the exact height is. We just look at this number right here, the power of the 10. So it doesn't make sense to say, oh, humans are about 2 meters taller than geckos. Humans are about 2 meters taller than ants. Because if you say that, you can't really compare in your head how big ants are compared to geckos. That might seem like kind of arbitrary, and it might be a little bit, but it is something that's on the Regents and AP curriculum once in a while, so it's worth mentioning. And it is useful because once in a while we'll talk about like there might be a problem involving like space travel, or there might be a problem involving like microscopic atoms, and we'll talk about both those things. So it's nice to have some way to relate them. It's just a good thing to know about when you're discussing math and science and numbers, and you want to be descriptive with your words. So it doesn't really matter the exact height. Let's say I have a bigger ant that's like 2.7 millimeters. Or let's say I have a little ant larva that's only 0.9, bad example, 1.1 millimeters. I would say a human is 3 orders of magnitude bigger than ants. So this is a 0, this is -3. So a human is 3 orders of magnitude bigger than this ant, but also 3 orders of magnitude bigger than this ant, and also 3 orders of magnitude bigger than this ant. It doesn't matter that it's not exactly 3. It's close enough. It's approximation. It's just helpful to express and to visualize how much smaller or bigger something is. That's order of magnitude. We'll come back to magnitude later, which means size, but that's the definition. So those problems I gave you yesterday, not too hard, pretty straightforward. If you can't find the value, I think I asked you for like the order of magnitude of the charge of an electron or something. Those are on the reference table and equation sheet. A lot of problems in physics, if you don't know a certain value, but it's like a set value in the universe, like the mass of the Earth or something, check the units table, check the reference table. It might be there. Or just Google it. You guys are remote learning anyway. And you guys have phones with you like all the time. That's order of magnitude. Good job. We're super smart. Okay, one more thing. Even a baby could convert 5 meters to centimeters, right? Right. 500 centimeters. What if I'm selling a very, very nice carpet, and I sell it by the square meter, and I say, oh wow, I need a really small little carpet for my room to put right in the center. I need only a 5 meter squared carpet. But my carpet is so fancy and so expensive and so precious. It's embroidered and like hand stitched, and it's just amazing. I charge per square centimeter. How many square centimeters are in 5 square meters? Daisy, what do you think? How many square centimeters are in 5 square meters? 500, because there's 100 centimeters in a meter. Well, what do you think? Do you agree with Daisy? It's not. If you're not convinced, think about it this way. Imagine a square foot. The tiles in the school, the tiles and this floor right here below me are each about 1 square foot. Think about a square inch. If you ever send a letter with like snail mail, which I'm sure you guys don't, a stamp is about 1 square inch. So do you guys think, well, if you know that 12 inches is 1 foot, do you guys think that 12 square inches is 1 square foot? Well, think about stamps and the tiles on the floor. Could 12 stamps cover up the tile on the floor? No, Mr. Lamb, they can't. Stamps are way too small. Thanks. Thanks, Sage. This is not correct. Why not? What did we do wrong? Here's the method. 5 meters squared times some fraction will give us the answer in square centimeters. Well, the fraction, we want to end up with centimeters, so we need centimeters on top. We want to cancel the meters, so we need meters on the bottom. What's this fraction? The top and bottom have to be equal, remember. 100 centimeters equals 1 meter. This is what Daisy did, but it doesn't work. Do you see why it didn't work? Tell me why it didn't work. Good job, you did it. It doesn't work because the meters are squared here and they're not squared here. To make them cancel properly, you gotta square this. So you're really doing 5 meters squared times 10,000 centimeters squared per meter squared. If you already realize that, good job. A lot of people make this mistake. They think, oh, 100 centimeters in a meter, just multiply by 100. It doesn't work if the centimeters and meters are not to the first power. So we get 50,000 centimeters squared. Another important thing in physics, never ever write a number without units. I'm going to take off half credit. It's not correct. Always include units in your answer. Never, if I ask you what's 5 meters plus 5 meters, 10 is totally wrong. Do not say that. You must have your units. You should really have units every single step of the problem. It helps keep things much more clear in my mind, easier to grade, easier for everyone. So please, please, please always have units. That's 2 things, real simple. We're gonna have lots of time to practice or maybe look at the homework. We'll do some more different stuff Thursday, Friday, and then we're gonna do some more real physics next week. Okay, see you guys then.